Maya, Sierra Beltran was looking for you. Okay.
Oh God, that's why she was looking for where I can fill out her journal.
Second request, please.
I should have known that.
I gave you a small reminder at the beginning of class yesterday that we can get clumsy and tangle biomass with nutrients. I can understand how that's easy to mistake. If you drop something into water, that'll make a lot of fertilizer because that'll be nutrients soon. But I need to clarify, today we're going to talk about nutrients becoming biomass and biomass becoming nutrients a lot. So make sure that you're clear on which one you're talking about, and don't forget the in-between step, the production or the decomposition. Quick review from yesterday. Two variables, shift in a flowing river when we add biodegradable material. Without biodegradable material, there is low demand for oxygen, but aerobic decomposers spike in activity when they're fed a lot of food. You proved that with your lab. You saw that the higher milk concentration ran out of oxygen faster. So dissolved oxygen is used up when there are inputs of food, which make decomposers more active. If you want in your notes, instead of BOD, you could just call that decomposer activity. And that's probably a good analog. These dead zones that result where oxygen is very low due to decomp, those are ecologically bad because of the changes in wildlife. They're also bad for us because we know what sorts of bacteria like anaerobic environments. You saw in the lab that there's always gas exchange on that top micro layer of water. So as the water keeps moving, gas exchange continues and dissolved oxygen levels would recover. This creates discrete zones biologically in a river. They have names. This all came out yesterday. I just wanted to walk over that one more time in case anybody wanted to ask me anything about that. Fine. Then please switch to your 7.3 notes. I wasn't going to show you this, but look, there's my belt. Okay. I'd like to talk about 34 and 35 today, and this is going to be slightly out of order. Remember, the study goals in this unit are all scrambled so that we can get all the right stuff ahead of Monday's field trip. And it wasn't really in your book, but I'd like you to have some notes on what we mean when we say wastewater. And I'm sorry, but we're going to talk about poop in the next 5 minutes more than ever in high school life. And I'm sorry that you had to come see me on the one day where I talk about poop nonstop. You should probably note that wastewater is all the drains in your home. And I know you're not plumbers, but that would be kitchen sink, dishwasher, washing machine, shower, bathroom sinks, and yeah, toilets. Yeah.
Are you talking about 34 and 35 like combined, or are you talking about 34? We're both talking about like wastewater.
Thanks for asking. Right now, I'm talking about 34 and 35 loosely combined. This would cover both. So all the drains in your home, the showers, sinks, washing machines, all that stuff. In our wastewater, all of that stuff is combined, and almost everything in wastewater is just plain, clean drinking water because our faucets deliver clean drinking water. Soaps of many sorts, and little bits of stuff. Every year when my students go to the wastewater treatment facility, I hear on the bus that they were surprised they never saw poops. And I have to talk about this. We're going to be talking about solids, like in the we'll talk about solids in a minute. I don't mean like poops, poops dissolve in water really fast. Poops are not solids. When all the drains leave your house and they join the big sewer pipes, it's basically 99.9% clean drinking water with some various household soaps and surfactants added, and then little tiny bits of biomatter. But I mean little tiny bits, like little paper fibers from shredding toilet paper, like little seeds that our digestive systems can't digest. Maybe little food scraps from like your dishwasher. And something that's really common in our wastewater is plain old grit, like sand. I have to get this in our heads first before I talk about wastewater treatment. Anybody want to ask me anything about wastewater? Okay. I'm so glad that we're in Santa Barbara because our textbook was written by Santa Barbara dudes. So when they talk about wastewater treatment, they show you the place we're going to go on Monday. Coincidentally, our wastewater treatment is world famous. There's like conferences, wastewater from all over the world that come here to see our wastewater treatment. It's excellent and well known. I will take you to see on Monday maybe this, but I doubt it. Definitely this. Maybe this. Hopefully that. And now I need you to note what happens here. The terms are universal. Anywhere in the world, all wastewater treatment has the same terminology. Bye, guys. Primary treatment is when we physically remove material. So first, we screen out big trash. People flush a whole bunch of condoms, plastic gloves, miscellaneous hygiene products, soiled undergarments. Toys are very common. Drugs are very common. Fish from time to time. Jewelry pretty often. Did I mention toys?
Yeah.
No.
Children put a lot of toys in toilets. A lot, because they can make them disappear. And so little kids do this like action and response thing where they like study consequences. So they're like, whoa, and they'll like put like all their toy soldiers or whatever.
My dog dropped his toy in the toilet one time. It was really sad. He got like really upset and he tried to like get it out.
Oh yeah. I'd have to shoot that dog. And now you gotta die, Charlie. Okay. In your notes, primary treatment is the removal of solids. And when I say that, even though I try to clear this up, everybody's like, oh yeah, the baby Ruth slide out the side. Like, nope. There's no more poop involved. Your poop is just water now. So when I say removal of solids, please look up. We screen out the really big stuff. We settle all the grit. And then we separately allow any fine sediment to settle. In your notes, I would write like plastic and trash, like stuff that shouldn't have been in there. P.S. They find tons of money. Like all those guys have really nice bikes because they get bonuses from the city if they commute to work. It's like a cool program where if you're healthy, you cost less in health insurance. So they get like use that to buy nice bicycles. And so their bike rack has all these like pimped out lowriders with like crazy scroll work and like crazy fiberglass road bikes. And it's like, how the heck do you have these crazy bikes? Yeah.
Can you say one more time? You said they like screen out the big stuff. What do they do with the grit?
Got you. Once you screen out the really big stuff, all the sand will just settle because, you know, it's heavy. And then in really big pools, if you let it settle, that's where you get all like the strawberry seeds and you know it, corn and like black bean skins. You know what I'm talking about. So you get solids removed in primary treatment. That's just mechanical. And that word is helpful in your notes. This isn't a chemical process. There's no weird tricks. You just screen out the big stuff and then gravity settles the little stuff.
You
Then
didn't answer your question. Where does the grit go? Like, do they just take it out?
oh yeah, they make it into compost.
Yeah.
Sorry, yes, all that grit, once it's settled, is actually separated and sold. So the trash goes into a trash dumpster. Like they have to line it with a plastic bag, I guess. But there's just like a big trash dumpster, and like the screen has like a chute, and like maybe we can walk by it. But there will just be this dumpster that kind of smells bad, and it's all got a big plastic liner in it. And there's just this like constant like extruded lump. It's like wet wipes.
Can you not walk past that part?
It's kind of rad. Because like there's always something visible in it that you didn't expect. It's like, oh, pencil! It's weird. You see a lot of stuff in there. All right. The grit and the sediment, once they settle, that becomes compost. Now, next. If you think about it, once you've settled all the solids, then all you have left is like soupy liquid. And I don't mean chunky liquid. I mean like broth. So secondary treatment is just water and macromolecules.
Wait, what about this sedimentation?
I'll get to that. So this is just more sludge settling. So usually the grit falls fast because sand is really dense. And then like all the seeds and organic sediment falls here. Now here, you just have like water with fat, sugar, proteins. Think about it. If you like cracked open a cell, what would spill out of that? Like all the organic compounds, and you have to know that word. Organic compounds or macromolecules, the compounds of life. If you didn't write this down earlier, I mean fat, I mean sugar, I mean protein. And in secondary treatment, we feed a bunch of oxygen so that decomposers will break those down into nutrients. Primary is the mechanical removal of solids. Secondary is the aerobic decomposition of macromolecules into nutrients.
Did you say that one more time?
Anybody, what?
Did you say the secondary again one more time?
Aerobic decomposition of macromolecules into nutrients.
So the sludge is the like organic foods?
Yeah, so it's basically all like the corn and strawberry
Those are things
seeds.
you couldn't digest.
Right. We can't eat any part of seeds. Like seeds are digestion proof, so that after you eat the fruit, you deposit the seed in a little pile of fertilizer somewhere. And so like, they make like literally barrels of strawberry seed at wastewater treatment facilities. Cause like everybody eats strawberries all year round. And they have like unbelievable volumes of corn. It's crazy how much corn there is. Anyway, all of that sediment, plus all the dead bacteria, like the leftover bacteria afterward, they can take all of that. And in Santa Barbara, we do something really cool and trick. This is not relevant to the AP test, just kind of a cool FYI. We take all of that sludge, and you know, that's still life, that's still biomass. So what they do here is we put that into a digester that's anaerobic. So all the carbons, instead of being stuck to oxygen, because it's anaerobic, they get stuck to hydrogen. And so this is like a giant intestine, and they make methane on site to provide their electricity. Because our wastewater facility is the largest electricity user in the county, they make their own rather than tax the grid. They turn all of your poop into farts outside your body. Let me say that again. They turn all your poops into farts outside your body, and then they light them. They light your fart for you that you didn't make.
And then it powers.
You should work there.
Yeah, they make electricity. Yeah.
To
Yeah.
make more farts.
Yeah. I can't believe you're not excited by this.
I can't believe you didn't end up working there instead of becoming a teacher.
My homie works there. He earns really well. Those guys are crazy well paid because they're all like expert, technical, really high tech plumbers that are like organic chemist nerds that are like environmentally woke and policy hip. Like those guys are a big deal. Okay. Oh, and they're all fit because they'll ride their bikes to work. Okay, so the secondary outflow, I don't think this was in your book. What comes out of secondary now is just water and a whole bunch of nutrients because you've decomposed all the organic material. So all that leaves is nutrient-rich water. It's basically fertilizer. And you may want to put a little star on the side. There's one thing that bacteria doesn't eat out of wastewater. Like soap is made to be digested by bacteria. And your poop all digests because that's what bacteria does in our body. But you know what's crazy? Something that leaves in our wastewater that the bacteria cannot digest is our freaking medicine cabinets. Our wastewater is fertilizer water plus a whole bunch of antidepressants and a whole bunch of stimulants and crazy loads of birth control and like a few strange oddball hormone treatments. There's like extra hormones, and then there's hormone suppressants. And there's also weird heavy metals from our diet. Bacteria doesn't eat any of that.
Does it all just cancel each other out?
It's like a really complicated chemical soup. Like if you wanted to drink all of that, you would have to do some super hardcore treatment. Like it's the same as desal. To treat wastewater, it's basically the same as the desal plant.
So we should just run it through the desal plant.
Oh no, if we did, we would have saved about half the cost. Because the only thing more complicated than wastewater is ocean water. The pipe that delivers this wastewater out to the ocean has another pipe glued to it where we suck in the salt water for the desal plant.
Is there a reason why we don't just...
Because Santa Barbara thought that would be too gross, so we just didn't tell them, and now we go like this with the two pipes.
What if we just didn't tell everyone?
I know. My buddy Kevin is like the lead technician for drinking water treatment in Santa Barbara County. And he's like, dude, we could have saved so much hassle. Dealing with salt water is so bad. Okay. Primary, secondary. Oh! And you'll notice that only says primary, secondary. I need you to add in your notes. Some places do tertiary.
Well, is that what they call advanced wastewater treatment?
Right? So here in Santa Barbara, we just dump our nutrient water. But there's something called advanced treatment or tertiary treatment, which is to soak up nutrients. Sometimes you can have too much of a good thing. We'll get to that at the end of this class. So tertiary treatment, not done everywhere. Tertiary treatment is take up of nutrients. It's absorption of nutrients. Up in Humboldt, please look up. Humboldt's wastewater goes into this really large bay called Humboldt Bay, and that water doesn't move very much. So if you dump a bunch of nutrients into water that's not moving, you can get negative problems. So what they do is they dump all of their nutrient water into a big wetland first, so that the wetland will absorb all the nutrients before it hits the bay. Here in Santa Barbara, our water is ripping. The California current takes our water and just flips it all over the ocean. So our nutrients can just go straight out into the California current, and then out there they don't really cause any problems because they just get stirred up so fast.
What about the leftover, like, medical waste?
That's just diluted into the ocean.
Do the fishies, does that have,
You know, like, imagine pouring dye into water, right? Like if that water's really stirred up a lot, the dye will disappear faster. So yeah, that's a thing. But luckily, our outflow is basically the same as just sprinkling across the Pacific because the California current is so powerful. But if you put all those hormones into a fixed body of water, you definitely tweak with wildlife.
that's so sad.
So I mean, that's the distinction. Like, just so you know, that like hormonally active agent is a type of pollution, and it's not a problem here because of our water dynamics. In a different aquatic system, that could be really harmful. Also, in number 34, we talked about your homework asked about septic tanks. Does anybody know if their house has a septic tank?
My grandparents' house has a septic tank.
Here or there?
Probably.
You do? And you live Santa Barbara County? Nice to do water treatment all at once. But if you're kind of like up in the hills where it's tough to get the plumbing, or if you're like at Rincon where you're just too far from plumbing, a lot of people use what are called septic tanks, which are just like a little tiny, finely tuned miniature wastewater treatment for a single house. Here's the things you have to know. please look up. A tank with a wall in the middle and a leach field. If you're going to draw this, draw it now. That's a septic tank.
Did you say leach field?
Leach, yeah. People call it drain field. In that image, it says drain field. And I think I spelled leach wrong on the whiteboard.
Yeah, you did. It has an A in it.
It's weird. Sometimes you can't remember a word, and then you start thinking about it, and then you remember that it was different than you thought. I'm so happy about my new green laser. It is so strong. Damn!
Oh, did you hear that? I'm
Yeah, I heard that.
And then she asked why we make fun of her.
I
like,
felt that. There was like a sharp knife in my lower back.
You shit in my cereal. Are you fucking kidding me?
Damn. I said that in a meeting with one of my assistant principals, and he didn't like it. I said salad, not cereal. Okay. In a septic tank, water flows in and water flows out, but because there's that wall in the middle, that causes splash on one side, settling of material here, the water's forced to flow through an area that has oxygen, doesn't have oxygen, and has oxygen before it goes out into the ground. So what you get is primary treatment where the solids are separated on the left, floaters stay here, sinkers stay there. So that's primary treatment on the left. Then you have bacterial decomposition of macronutrients or macromolecules going through that water, so that flow is the secondary treatment. And where the water goes out into the ground, you have to have vegetation to absorb the nutrients. That's tertiary treatment. So that after the leach field, all you get is groundwater recharge. That sounds pretty shaky. When septic systems work, it's no big deal. Awesome. Great.
When you don't?
When they break, it's gross. The problem that they had at Rincon is a lot of those houses had really old tanks with crappy lids that would just shift or break or get left open by somebody on purpose or by accident. And then during heavy rains, these would fill up with rainwater and stuff would float out and then go out to the ocean. I have literally padded across the Rincon river mouth and put my hand on a turd floating in the surface of the water. Like, that's not how they're supposed to work.
No, I thought you had a snack.
That's not how they're supposed to work. That's not how they're supposed to work.
Is that how they're supposed to work?
Yes. The thing about septic tanks is if they're dialed just right, it's great. Like, for all you know, that septic tank's been working for 500 years and it'll keep working forever. Mine, at my house up on West Camino Cielo, was hand-built probably in the 50s. The entire house like fell apart in a mudslide, everything moved. We checked it, septic tank was still cherry, no problem, perfect. But when they fail, it can be kind of gnarly. They also take a little bit of maintenance. Somebody has to come out and remove this from time to time. Okay.
Are they more or less expensive than sewer systems?
I would assume that for the homeowner, they're a lot more expensive because there's like an economy of scale. We all pitch in like $10 to participate in that. But to buy one of these for your house and then install it is thousands and thousands of dollars. And this can be really expensive too, you know, like getting all that plumbing into the ground. Yeah.
Are we gonna talk about the optional chlorine treatment?
Yeah, so I wasn't planning to. I could answer that for you really fast. if you think humans are going to interact with your outflow, then you have to treat it with chlorine so that there's no chance of bacteria surviving. Here in Santa Barbara, it goes through an ultraviolet filter that kills anything alive. Then they add chlorine anyway, and then they dump it out into the ocean because they're just like doubly thorough. Oh, by the way, they dump 2/3 of it into the ocean, but they send 1/3 of it back into the parks. Okay, last thing to discuss today is those nutrients I've been talking about. Remember that the outflow is nutrients. Secondary outflow is nutrient water. For study goal number 26, all life on Earth needs nutrients, but sometimes you can have a problem of too many nutrients. Sometimes you can have a problem with too many. Vocab term, many ecosystems are naturally low in nutrients. We call those oligotrophic. Oligotrophic. That means low nutrient levels. Oligotrophic. Like that one. Think about it. How many nutrients could possibly get into this lake? There's basically snowmelt, rocks, maybe a few trees. But pretty much any time that you're at high elevation, water doesn't really have a lot of nutrients. Water is just basically lifeless. I spend my summers, blah, 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 and see everybody knows this. And I have seen lakes that are just snowmelt. Nothing else.
Does that make them any less, like, healthy?
No, they're just really simplified. There's like no life in there. Maybe by the fall they'll develop like a couple of insect larvae or something, but like no vertebrates or anything. And then there are some environments that have a lot of nutrients. Think about like a swamp or a wetland where everything drains out of the watershed and decomposes. Those are called eutrophic. That means high nutrients. And remember, sometimes this is natural. Sometimes this is natural. Some environments can have high nutrient levels naturally. That's not a problem. That's just a thing. But I want to talk about what happens when humans add too many nutrients. There was a really famous example of this in Seattle, I believe. Somewhere in Washington. I think it is Seattle. Where a city just put all their wastewater treatment water, all their treated wastewater, into a big lake. So they just added nutrients, and then they added nutrients, and then they added nutrients, and tomorrow they added more nutrients. And remember, all life needs nutrients. Nutrients are a good thing. When you add nutrients, plants start to grow, and plants start to grow, you start to get bugs. But their lake kind of turned into this. When it stopped draining out into the ocean. There's two types of cultural eutrophication I want to talk about. Remember, eutrophication is when we add more nutrients. There's two types. In lakes, you get these. They're called algae mats. You can see it's like a mat on top of the water. Algae mat. Mat, like a...
Matt Reality.
Yeah, like Matt Reality. Yeah. Anybody heard from Matt Reality? What's he doing?
Yeah, he was
He
making
did
fun of
CC.
me yesterday.
He did what to you yesterday?
He just like randomly just like started making fun of me.
Good for him.
I think it's been a lot more than, I think it's been a lot more than yesterday.
So I mean like he's alive.
Oh, yeah.
Yeah. He started surfing.
Huh. Power to
He has
him.
a lot of free time.
Yeah. He's just cruising, roaming the earth.
He shows up in my math class occasionally to talk to Lily Wilson.
Oh yeah, he's really loud and annoying.
I think he's coming today. I think he's coming today.
Wow. So much winning. Algae mats have a couple of big problems that you should know. They prevent gas exchange and they block out light. No, this is something that you have to know. They block out light and they prevent gas exchange. They keep this from happening. So when you put a bunch of nutrients into water, you can get a pretty serious killing of the lake because you don't have gas exchange and they block out all the light. And something that your book does not talk about at all, which is actually a much worse problem, is this one. It's called coastal eutrophication. And this is a whole chain of events and students never explain it right. I have to warn you, it's been on many AP tests. America. Corn. So, fertilizers and little pieces of corn and stuff. At the end of corn season, you basically have this like corn nutrient soup spilling out into the Gulf of Mexico. Right when that water is the hottest, and the Gulf of Mexico, this is a special and scary thing. Please look over here. It's basically closed off. That water doesn't circulate very much. Remember, here where we live, when you put some water outside the California bight, the California current just rips that water away. But here, that water just sits there. It creates a problem called coastal eutrophication. And basically, this is like the biggest die-offs in the ocean. It's the most damage in the ocean, ecologically speaking. Watch me. Step 1, add nutrients. Step 2, food web explodes. It's a good thing. Everybody likes nutrients. So you get more producers, you get more consumers, you get little fish coming over, then the big fish show up. The problem is not actually the nutrients themselves. The problem is what happens when the nutrients wear out. What's going to happen? Yeah. And then when you have a bunch of dead stuff on the bottom, what's going to happen?
It's gonna wash up on the surface. Red tide.
Yeah, decomposition is going to happen. And so we get these giant ocean dead zones. Explaining this is like an Achilles heel for AP students. Like nationwide, we are cautioned to give you a heads up, like, just so you know, the kids always do a bad job on this one. So look, where we add nutrients, you get an explosion in the food web, but when the nutrients run out, then you have a big die-off, and the decomposers use up all the oxygen, and everything dies. Ocean dead zones. The world's largest ocean dead zone, the biggest on the whole planet, is right there. Every year, the Gulf of Mexico coastal eutrophication dead zone is bigger than the year before. Last year we broke the record from the previous year. I'll bet you that 2020 will be bigger than 2019. Sometimes there's a little one off the Klamath, but usually not. San Francisco Bay has hella current, so it doesn't really matter. Here in Santa Barbara, it's not a big whoop. They get some off TJ, actually. Usually it's pretty small, but wastewater treatment in TJ is kind of not that great sometimes. And so like right at the US border, there's sometimes a dead zone right there. A couple of these rivers make smaller dead zones. There's a bunch in the Mediterranean and like around the Persian Gulf, Arabian Peninsula stuff. There's a couple in shallow waters of Asia, but the worst on the planet is ours. And because there's a lot of students who take this class around here, the College Board asks this question a lot. Check your notes, this is the last time I'll say it. You add a bunch of nutrients, you get an explosion in the food web, but when the nutrients run out, die-off, decomposition, dead zone. No dissolved oxygen. I've seen videos of like a fishing boat captain that would be like, holy crap, look at this. And they'll like pull up on these like oil slicks of dead fish floating on the surface. Like sometimes the oxygen levels drop so fast that the fish can't get out. And they'll just like run out of oxygen. They'll come to the surface, try to breathe, and the water's all hot, stagnant. And they just like belly up and like mile around. Would you turn that off on me?
So